Hey everyone, let's solve the two-sum problem. This is a super classic interview question. You're given an array of numbers and a target value, and you need to find the indices of two numbers that add up to that target. The key constraint here is that you can't use the same element twice, and you need to return the indices, not the actual values. Let's see how we can tackle this. Let's walk through an example to understand the pattern. We have the array 2, 7, 11, 15, and we need two numbers that sum to 9. When we look at 2, we ask ourselves, what number do we need to reach 9? We need 7. When we move to the next element, which is 7, we ask the same question, what do we need? We need 2, and we've already seen 2 at index 0. So we return 0, 1. The key insight here is that we're looking backwards to see if we've already encountered the complement. The first thing that comes to mind is the brute force approach, just check every possible pair with nested loops. That works, but it's n superscript 2, which is way too slow. Here's the aha moment, instead of searching for pairs, what if we remember what we've already seen? We can use a hash map to store each number and its index as we go. For each new number, we instantly check if its complement already exists in our hash map. This brings us down to n time with just a single pass. Let me break down exactly how this works. We start with an empty hash map called scene. As we iterate through the array, for each number we calculate what we need to reach the target. If that needed number is already in our hash map, boom. We found our pair and we return both indices. If not, we store the current number and its index for future lookups. This way, we're building our knowledge as we go, and each lookup is instant because hash maps give us 1 access time. Here's the actual code, and it's beautifully simple. We create our hash map called scene. Then we loop through the array with enumerate to get both index and value. For each number, we calculate what we need to hit the target. If that needed value is already in our hash map, we return the indices immediately. Otherwise, we store the current number and its index. That's it. The elegance here is that we're solving the problem in one pass while building our lookup table on the fly. Let's wrap up with complexity analysis. Time complexity is n, because we only pass through the array once, and each hash map operation is constant time. Space complexity is also n, since in the worst case we might store almost every element. This is optimal because we can't do better than n time, we have to look at each element at least once. The big takeaway here is the pattern. Whenever you see a problem asking for a pair that sums to a target, immediately think hash map and complement lookup. Master this pattern and you'll crush similar problems in interviews. Great job working through this.